The sun's core is the hottest part of the sun, but our star's temperature doesn't behave as you might expect. The core is roughly 27 million degrees Fahrenheit and 10 times more dense than gold. As you move outward, the layers of the sun become cooler and less dense. Something unusual, however, occurs when you reach the outermost layer. While the surface is around 10,000 degrees Fahrenheit, the corona, the sun's outer atmosphere, is several hundred times hotter. That's the opposite of what happens with a fire. When it gets cooler, the farther away you get. Scientists call this the coronal heating problem, and evidence for this was first uncovered during an eclipse in the 1800s. The corona is usually hard to see. It's too dim to be seen next to the sun's bright body, but it can be seen with the naked eye when the moon blocks the sun during a total solar eclipse. To understand how this mystery was discovered, it helps to know how scientists started studying the chemical properties of materials on Earth. In the early 1800s, instruments named spectroscopes were invented to identify materials that emit light when heated. Light enters the spectroscope and is filtered through a tiny hole to isolate a single area. It then bounces off a special grating that disperses light into its different wavelengths. While sunlight contains every wavelength, scientists discovered that every chemical element and compound contains a unique pattern of wavelengths that allows scientists to determine the composition of light sources. It wasn't long before astronomers started extracting information from the light of distant stellar objects. In 1869, two scientists independently decided to point a spectroscope toward the corona during a total solar eclipse. As the sun's light disappeared, the pattern of wavelengths changed. They saw something they had never seen before. A bright green line that did not relate to any element found on Earth. For a short while, scientists named it coronium. It wasn't until 70 years later that a Swedish scientist discovered that these lines were the result of elements such as iron being stripped of its electrons. Every element has a specific number of electrons surrounding the nucleus. As each electron is removed, more energy is needed to remove the next one. The green line shows that iron has been stripped of 13 of its 26 electrons, indicating that the corona needed to be millions of degrees, counterintuitively far hotter than the sun's surface. Scientists have since proposed a variety of theories for what mechanisms could be adding that extra heat into the atmosphere. One theory suggests that small waves in the sun's surface pushes particles and heat into the atmosphere, a bit like how ocean waves push surfers. Another theory suggests small bomb-like explosions from the realignment of the sun's magnetic field create heat. Many scientists think it may be a mix of both. We've studied the corona from Earth during many eclipses, but to solve our star's biggest mystery, we have to make direct observations from the region itself.